the mighty diesel-electric locomotive. It's the business end of a train. To some, all these may look the same, but there's plenty of variety out there. From pulling passengers to hauling freight. Coming up, I'll tell you all you ever wanted to know about modern diesel-electric locomotives and more. We'll take a look under the hood and go inside the cab. And we'll examine the features that keep crews and the public safe. Plus, some of these may look like locomotives, but they're actually not. All that and more is next on this V12 production special. Hello and welcome to this V12 production special. Today we're talking all about modern diesel locomotives, or should I say diesel electric locomotives. These machines are packed with high-tech electronics to help them operate more efficiently and safely. But the basics of how they work haven't really changed in more than 100 years. In this special, we'll discuss the various types of units that you'll see on the rails today, and look back at the evolution of North American locomotives. But first, let's test your knowledge. What exactly is a diesel-electric road switcher? Well, here's the AI answer to that question. It doesn't look quite right, but it's also not too far off. However, AI does not seem to understand what a yard switcher is. So sit back and let me show you the real thing. We'll start with how locomotives work. Well, the way these things work is really quite simple once you take away all the modern electronics. Think of a locomotive like a rolling generator. Large engines, known as prime movers, make all this possible. For decades, two big corporations were the primary builders of these engines: General Motors and General Electric. GM's Electromotive division is now owned by Progress Rail, a subsidiary of Caterpillar. And traditionally, EMD preferred two-stroke diesel engines. Meanwhile, GE Transportation is now a division of Wabtec, and GE preferred four-stroke diesel engines. Both companies utilize turbochargers to maximize horsepower. However, these big engines are not mechanically connected to the wheels like on your car or truck. They actually spin either an alternator or a generator which produces electricity. That electricity is used to power electric traction motors that turn the wheels. And a useful feature of a locomotive's electric traction motors is that they can essentially be turned into resistors to slow a train down. This is known as dynamic braking. You can actually hear the engineer using his dynamic brakes here. Of course, locomotives also have air brakes. In the cab, the engineer has an independent brake that only activates the brakes on the locomotive, and an automatic brake that activates the brakes for the entire train. So what about those traction motors and what are known as the locomotive's trucks? Well, up until the late 20th century, manufacturers relied on direct current or DC traction motors. However, in the past 30 years, railroads have begun to buy and rebuild locomotives with alternating current or AC traction motors on a large scale. AC motors provide better adhesion, less wheel slip. They're also more reliable, simpler, more rugged, and more efficient than DC motors. Of course, with huge engines under the hood, locomotives like these need some serious cooling power. Radiators are usually housed towards the rear of the unit. And, believe it or not, locomotives are typically water-cooled and do not use antifreeze. The radiator sections of locomotives have increased greatly over the past 50 years. Here, we're talking about cooling water, oil, and perhaps most importantly of all, air. Cooler, denser air has more oxygen, which helps to increase efficiency and power. Lower engine air intake temperatures also helps to reduce emissions. Modern locomotives also recirculate exhaust gases to decrease pollutants. As you can see, even rebuilt locomotives like this bizarre-looking ST23 T4 have some serious cooling power. Now there's lots of technology on board that I'm leaving out, but that's a basic explanation. Okay, let's take a break from the trains for a minute and talk about something that could earn you some cash back on things you do every day. Now, I don't know if you've noticed, but there is a lot of footage from all different locations in this video, and that means a lot of driving. And of course, a lot of driving can mean a whole lot of gas. So lately, I've been using the free Upside app, and I think you should check it out. I mean, it's really easy. I just pull up to the gas station, open the app, and claim the offer. Now, you may not be driving all around the Southeast recording trains like I am, but maybe you're commuting to work or driving the kids all around town. I'll bet the Upside app could fit into your life. Maybe you're saving up for the holidays or your next road trip. Oh, and by the way, there may even be cashback opportunities at the grocery store or your favorite restaurant. Now, Upside has given back $1 billion to its users. To find out how much you could earn, download the free Upside app and use promo code Locomotive to get an extra 25 cents back for every gallon on your first tank of gas. That's an extra 25 cents back for every gallon on your first tank of gas using promo code Locomotive. All right, let's get back to the trains. Obviously, there's not just one locomotive model out there, although sometimes it does seem that way. One company definitely dominates the market. So next, let's look at the different types of units and see what they're used for. Today, the most common type of locomotive on the rails in North America is the road switcher. It's capable of pulling trains on the main line or switching cars at an online customer or in a rail yard. These have either 4 or 6 axles. Typically, road switchers feature an operator's cab at the front with a long hood behind it. Diesel-electric locomotives can travel the same speed going in either direction, and they are set up to be operated bidirectionally, although the crew will have less visibility when the unit is running long hood forward. So let's start by looking at smaller 4-axle road switchers. If you see one of these, it's most likely going to be a Jeep, and by that I mean a locomotive that's part of Locomotive Division's GP or General Purpose series. This all started in 1949 with the 1500 horsepower GP7. The GP series of locomotives was extremely successful for General Motors. But it wasn't the very first successful road switcher with this design. Alco, or the American Locomotive Company, had its RS-1 back in the 1940s and 50s. But Jeeps definitely proved how versatile a hood unit design could be. They made maintenance easier and increased visibility when crews were switching, a task that requires lots of forward and reverse movements. In freight service, this was a great improvement from earlier locomotives that were cab units where the body extended the entire length and width of the machine. EMD F units were the most popular example of this design. They were used in passenger and freight service. Here, the body was also load-bearing. Under its cosmetic panels, you would have seen a structure designed like a bridge truss. These had very poor rear visibility and could be challenging to service. Of course, many of these ran in sets with an A unit hooked up to a B unit. The B units did not have operators' cabs. These days, railroads big and small still heavily rely on various generations of Jeeps. You'll often see these operating on short-distance local trains and in yard service. Many Jeeps have been rebuilt and, in some cases, repowered, extending their service lives. Now, General Electric also had success with some of its lines of 4-axle locomotives. They made quite a splash in the mid-20th century with their Universal series. However, 4-axle GEs are not as common in the 21st century. Some short lines still run them, but many of the Class 1 railroads have taken 4-axle GEs off their rosters. From what I've heard, it's easier to find parts for the older EMD locomotives. But while the smaller GE locomotives are getting harder and harder to find, the big ones are everywhere. Spend any time next to a Class 1 railroad's main line and you'll probably see one. Most likely, a big 6-axle unit that's part of General Electric's Evolution series, what rail fans call GEVOs. In the 1980s, GE started to pull ahead of EMD in the locomotive market. For many years leading up to this, EMD had dominated with its GP and SD series. SD stands for Special Duty. The most successful model in the SD line was the EMD SD40-2, a 6-axle road switcher with a turbocharged V16 producing 3,000 horsepower. These were, and still are, extremely versatile and reliable and can be found on Class 1 and short-line railroads all over North America. But unfortunately for EMD, nothing that followed the SD40-2 ever matched its success. GE started building locomotives in its Dash 8 series in the 1980s. There were 4 and 6-axle variants. This one is what CSX designates as a CW40-8. It has 6 axles and a turbocharged V16 producing 4,000 horsepower. Several years later, this engine, the Dash 9, helped make GE a frontrunner in sales over its competitor EMD. And starting in 1993, GE began to implement technology that would further revolutionize its modern locomotives. This is the AC 4400CW. The AC means it has alternating current traction motors, something that would help railroads do things like haul really heavy coal drags. Also, in 1993, EMD came out with this, the 4,000 horsepower SD70 MAC. It looks similar to its DC traction cousin, the SD70M, but is 2 feet longer and has special vents on both sides for its AC traction equipment. Thousands of these SD70 Macs would be produced, and Burlington Northern was a big customer. They needed these to pull heavy coal trains out of the Powder River Basin. But in the 21st century, GE would have another major success. The first GEVO, as many of us call them, came on the scene in 2002. These units have a 4-stroke, turbocharged, 4,400 horsepower V12. Various iterations of the GEVO are commonly seen leading long-distance freight trains. And this is EMD's 21st century road switcher, the SD70 ACE, which is equipped with a 4,300 horsepower, turbocharged 2-stroke V16. But don't mistake this for an SD70 ACE. Like GE, Locomotive continued to make DC traction motor equipped road locomotives into the 21st century. This SD70M-2 looks very similar, but is missing the AC traction motor air intakes behind the left side of the cab. Only a few Class 1 railroads bought these. This one is ex-Norfolk Southern and now works for Caterpillar at RailNet down in South Georgia. Now, you might even see the even more modern SD70 ACE T4 out on the main line. It has an EMD 4-stroke V12 diesel engine. That's right, EMD finally moved away from a 2-stroke engine and also increased displacement. Now, many of these newer locomotives are equipped to run as unmanned, distributed power units in the middle or at the end of a train. DP units use a radio link to the head-end locomotive to receive throttle and braking commands. By distributing the motive power in the middle or on the end of a train, the forces on the draft gears and couplers are reduced. Just think about all the forces those draft gears and couplers are subjected to on a heavy train. Adding a mid-train DPU to help push and pull can help reduce those forces and enables railroads to run much longer trains. And it can also help maintain air pressure throughout the train. That's a very simplified explanation, but hopefully it gets the point across. Meanwhile, some of the older road switchers have been relegated to yard service. and some of these have been outfitted to be remotely controlled by a single operator who uses a special belt pack. From big to small, the next type of locomotive isn't seen much anymore on the big Class 1 railroads, but it definitely paved the way for the units that came after it. Long before GE dominated the locomotive market, they were making these small switch engines in addition to components for other locomotive manufacturers. Some of the company's little switchers were bought by railroads, while others worked for rail-served industries. In the era of steam, switchers were often the first type of diesel locomotive a railroad would purchase. Unlike GE's center cab design, the design that was settled on by many manufacturers, including EMD, was a hood in the front and a cab at the end. Some call these butt heads. Switchers were some of the earliest production diesel-electric locomotives. Typically, they're geared for slower speeds than road switchers. They have high tractive effort and can handle lots of low-speed starts and stops, and hours of pulling and shoving cars. Plus, they have lots of windows, meaning plenty of visibility for the engineer. Over the years, some railroads also used cow-calf sets where both units had a diesel engine. But that is not what you're looking at here. Many in-cab switchers are still earning their keep on short lines. And that's definitely the case here on the Sandersville Railroad. But their lash-ups are a little more distinctive. They call the cabless unit here a booster. However, the more common name for it is a slug. It has no diesel engine and uses the electricity produced by the mother unit to power its electric traction motors. These machines are great for jobs requiring maximum tractive effort at low speeds, like what they're using it for here. Diesel-electric locomotives can't effectively use all their power at low speeds. In fact, their wheels could slip if too much power is applied while pulling a heavy load. But applying this power to the extra traction motors on the slug helps them achieve greater tractive effort. Now, in the early and mid-2000s, railroads also experimented with gen sets for switching and short-haul duties. Basically, these were locomotives with multiple small diesel engines which could be turned on and off based on how much power was needed. This was intended to be a lower emission design with increased fuel savings. However, the design was actually quite complex and the little engines lacked the ruggedness of a conventional prime mover. You know, hauling people is a little different than pulling freight. Passenger locomotives are expected to accelerate quickly and are geared to run at faster speeds. They also need special head-end power equipment to provide electricity for the passenger cars they pull. The passenger locomotives in service today work in intercity, regional, and commuter service. Although it was originally designed for short-haul routes, the EMD F40PH ended up being Amtrak's workhorse, pulling cross-country trains. It was adapted from the EMD GP40-2 freight locomotive. Original F40s from 1976 had a two-stroke turbocharged V16 with variants of the unit producing between 3,000 and 3,200 horsepower. This is what's known as a cowl unit, and its body extends the length and width of the locomotive. However, the body itself does not provide any structural support, as was the case with the EMD F units we saw earlier. Now, some F40s have been rebuilt and are still in commuter service. They were ultimately replaced on Amtrak's long-distance routes by locomotives in GE's Genesis series. The most common variant is the P42DC. Debuting in 1996, it has a four-stroke turbocharged V16 producing 4,200 horsepower. Unlike the F40s, this has a monocoque car body, basically a unibody design similar to the F units long before it. Genesis series locomotives are still in service, but many are now being replaced on long-haul routes with the Siemens Charger. The engine in these is a Cummins 4-stroke V16 producing 4,200 horsepower. In addition to the Chargers and Genesis locomotives, Amtrak also rosters some oddities like GE-8s and EMD Jeeps. Although these units are mostly used for maintenance of way trains, backup power, and switching. So that's what's pulling long-haul passenger trains, but what about commuter operations? Well, there are quite a variety of units out there. In the late 1980s, 1990s, and early 2000s, EMD built the F-59PH and the F-59PHI for commuter service. These have turbocharged 2-stroke V12s producing 3,000 horsepower. The F-59PH has a boxy appearance while the F-59PHI is streamlined. Over the years, smaller manufacturers have also built or rebuilt locomotives for use in the commuter market, and the Siemens Charger has also been ordered by various agencies. In addition to traction motors and big engines, locomotives also feature many external features that make sure they're seen, heard, and most importantly, safe. These days, modern road locomotives are equipped with the North American cab, also known as the safety cab. The wide nose here provides added crew protection compared to what's known as the standard cab, which was present on most new locomotives into the mid-1980s. The visibility on these is good, but the front-end protection could be better. On a wide-nose diesel, the nose of the engine is heavy steel, thicker than sheet metal. And vertical collision posts inside provide further protection. At least on the outside, General Electric safety cab design hasn't changed much since it was first introduced. However, Canadian National did order some of its units with a slight variation. Meanwhile, EMD wide-nose cabs have evolved slightly over the years. Here's an SD70M and an SD70 ACE. Finally, the SD70 AHT4. Now, some rebuilt engines also feature an updated standard cab. And Norfolk Southern has this wide-nose design that they call the crescent cab. Oh, and if you were wondering, yeah, locomotive noses also house a toilet. There have also been some pretty unusual and distinct cab and body designs in the past 50 years. Famously, the Southern Railway ordered its road diesels with high noses and operated them long hood forward. I've talked extensively about this in previous videos. Oh, and how about this? Seaboard Coastline had 10 of these GE BQ-23-7s. The Q stood for crew quarters. This was during a time when railroads were trying to eliminate the caboose and fit everyone at the head end of the train. Photographer Stuart Lodge captured these after CSX plated up the cabs and converted them into B units. As you might imagine, there have been tests done to determine the effectiveness of the wide-nose cab. Several videos of tests like these are available on the FRA's YouTube channel. These studies are from the early 2000s. The results are available on the National Archives website. There's no audio in these videos, but I think you can imagine what these impacts sounded like. The cab in this test held up well after hitting a truck hauling logs at 50 miles per hour. The metal of the nose was bent, but the researchers found that if humans were inside the locomotive cab, they would have been okay. The FRA also did tests with rail cars, and the wide-nose cab performed pretty well. One takeaway from this footage is that most freight cars don't have anti-climbers, although I don't know that it would make much of a difference. Maybe an expert can weigh in on this. Now, there was one test where the wide-nose cab was badly damaged. Here's the locomotive hitting a trailer hauling 2 steel coils at 58 miles per hour. The steel coil at the back of the trailer here weighed 35,000 pounds. The impact was intense and caused severe damage. The right collision post inside the nose of the locomotive sheared. Also, after the impact, the researchers had trouble analyzing the data from the crash test dummy inside the locomotive cab. This was more of an extreme test which showed the cab's limits. Of course, locomotives also have to be seen and heard. Headlights have to be on when a locomotive is in use, even during the day. And since 1997, leading locomotives that travel at a speed of 20 miles per hour or faster over one or more public grade crossings have to have functioning ditch lights or auxiliary lights. Those are the lower two lights you see here. Some locomotives are set up to have their ditch lights flash when the horn is blown. And like the automotive industry, railroads are beginning to adopt LED headlights and ditch lights. So what about windows? Well, according to Federal Railroad Administration regulations, they should be able to withstand a ballistic impact with a standard .22 caliber long rifle lead bullet of 40 grains, and also the impact of a cinder block. That goes for both the front and side windows. Now, I've saved two of the most obvious safety features for last: horns and bells. Rail fans love horns, but some members of the general public do not. No doubt we've all heard that standard crossing sequence: two longs, a short, and a long blast held until the locomotive occupies the crossing. Pretty much every modern locomotive has a multiple chime horn. They look like this. As for bells, some are pneumatic, like this one. But this does not look like a bell. It's electronic and basically just plays bell sounds. The function of horns and bells is pretty straightforward, but why would a locomotive need sand? Well, sanders aimed where the wheels meet the rail increase traction in slippery situations or on steep grades. These big machines also require a lot of fuel. Locomotives like this AC 4400 CWM have a fuel capacity of 5,000 gallons. On that big fuel tank, locomotives also have a fuel cutoff button in case of emergencies. And we'll round off this list of interesting external features with the MU, or multiple unit connections, that allow one engineer to control multiple locomotives. As you might already know, locomotives can last a long time. In fact, many of the Class 1 railroads in North America have opted to rebuild older units instead of buying new ones. I could probably make an entire video about this. Norfolk Southern is conducting one of the biggest rebuild programs. It's taking its older GE-9s out of service and converting them into AC-44 C6Ms. The biggest addition here, the DC traction motors are swapped out for ones using alternating current. While these are very common, there have also been plenty of unusual rebuilds. Some locomotives are ultimately converted for maintenance of way service, while others still look like locomotives but are actually not. Norfolk Southern uses this machine in its research train to do inspections and gather data about its tracks. Meanwhile, CSX has converted this locomotive into a tool used to train first responders. Some passenger operations are also using gutted locomotives as NPCUs, or non-powered control units, for push-pull service. Some call these cabbage cars because they feature an operator's cab and a baggage compartment. This is by no means a comprehensive look at every locomotive model on the rails today, but hopefully this helps you understand the basics. Obviously, we didn't discuss electric passenger and freight units. Now, if you're wondering what the future of motive power looks like, well, click on the link in the end screen. We'll talk about hydrogen, batteries, and hybrids. Anyway, that's it for now. I hope you'll consider subscribing to the channel if you haven't already, and as always, thanks for watching, and I'll see you next time.